coach here, and he will be talking about one of the most exciting and hot areas in big data these days, which is deep learning.
Yeah. Hi. So I'm Gauthier Berthoud. I'm a researcher at the Swedish Institute of Computer Science. I was supposed to do the presentation with Jim Dolling, but he couldn't come here today. So what I will speak about is deep learning on how the platform we are developing can help people to start with deep learning. Because the thing is that my team at the Swedish Institute of Computer Science, and we have created a startup, and what we are doing is developing a new Hadoop distribution. It's the first European Hadoop distribution, and some aspect of it can be very useful for starting with deep learning. So to start with, raise a question, what are the factors that hold back artificial intelligence today? If we look at Bender, we can think that it's alcohol and sex, but according to Andrei Karpathy, I don't exactly know how you pronounce his name. If you don't know him, he is working at OpenAI. And his blog is a quite influential blog in deep learning. So this citation is taken from his blog. And he said that there is 4 factors that hold back artificial intelligence. First one is the compute. It's the compute power we have. So this is hardware. This is how much machine you have, how powerful are your GPU, CPU, and things like that. The second one is the data. Is that to do deep learning, you need big data. You need big data that are clean, and right now it's not so easy to find them. The data are kind of all over the place on the internet. Don't really know where to find them. Then when you find some data, you don't know if they are really clean, and things like that. Then the third component is algorithm. So it's what you will do if you work on, if you want to develop new artificial intelligence system. And the last one is infrastructure, is what do you run your deep learning system on. So it's the operating system, but also where you store your data and things like that. And what our platform address, the problem that our platform address is the data problem and the infrastructure problem. So we'll start with the data problem. So the data challenge, how do you find good and interesting data? Okay, if you are in a big company, you are Spotify, or you have the data that are there and you can use them. But if you are a hacker or a researcher and you want to experiment with data, you don't necessarily have them there and you look for them. And then right now it's kind of going to IKEA, but going directly to the last part. You have data all over the place. They are all in box. You have to find the box that go together. You have to bring that out at home by yourself. And then you build it, and then you find out that, oh, it's not what I wanted. So how can we help with that? Yeah, and then the other problem are, as I say, you bring it back home. How do you do that right now? Is that we don't see, but it's not so important. It's a line of code that tells you how to download some data from S3. And most of the time you have to run it 100 times to have all the data. And if one of them crash in the middle, you have to do it manually to find out. We had a student, a PhD student, downloading weather data, and it took him 1 week the first time, and then he re-implemented the client to download the data, and it went a lot faster. And then if you have data and you want to make them public, how do you do that? There is no straightforward solution now. You can put them on Amazon or on Google Cloud, but then who pay for that? Who pay for each time someone downloads? And then you have to make some web page to publish them and things like that. no very nice platform where in few clicks you can say, okay, now my data are public. And this is what this is one of the things we do in our platform. I wanted to make a demo, but the problem is that I can't connect my computer to the video projector, and the demo. So I will describe the demo and show some screenshots. Because the demo is running, we have deployed 2 virtual machines in my lab, and I need my computer to access to them because of firewall problem. But so the idea is that we had 2 virtual machines with a full stack with the hop stack, so which contain we store the data in HDFS and then use yarn and things like that. So it's a full Hadoop stack, and we have data in there, and we want to share them. And we have a nice interface to see our data in the HDFS. I will show it a little more when I speak over the infrastructure, but we have data in one of the virtual machines. And what we do is just we right-click on them and say share this data. Here there is a share the data. And then these data are now public. And they have a description, which is a file, a README file that is in the folder and that describe what are in the data. And then on the other virtual machine, we can search for the name of this data, or for something in the description. We use Elasticsearch for the research, and we will find we'll get the result there of all the public data sets that are there, and we will say, okay, download it. And yeah, screenshots are very bad. When we download it, we say to which project we want to add them. And then if it's HDFS, we can directly dump it to HDFS, or if it's stuff that have the good format for Kafka, we can also put them in Kafka. And once we have done that, it starts downloading, and we can start processing on them. How does it work in the background? It's a peer-to-peer torrent-like protocol. So if a lot of people have this data set in their cluster, then it will go faster to download them. And then we'll use the LabDAT for the transport protocol. The idea is that LabDAT is non-obtrusive. So we know that if you have data sets that are public, it may not be your priority to upload them to people that want to download them. Your priority is to serve the people that use your cluster directly. So LabDAT is good for that because it will use only the bandwidth that is not used by TCP. And so if people are not using your cluster, it will be able to upload at maximum speed. But as soon as you have TCP connections that start to use your cluster, it will go down and use less bandwidth. The other interest of LabDAT is that it works a lot better than TCP over high latency, high bandwidth connection, which are the connection you have when you have cluster on both sides of the Atlantic or things like that. I had numbers, but because the problem with TCP is that the congestion windows is badly reacted to high latency, and so when the latency increases, the throughput at which TCP can transmit over the network is going down. LabDAT is measuring the latency and is looking at the change in latency to know if it should decrease or increase the throughput at which it's sent. And this has also the advantage that it handles better packet loss, because it will not take a packet loss as, okay, now I need to decrease the size of my windows by half. It will say, okay, there is one packet that was lost, but globally the latency is the same, so maybe it was just this packet, which can happen on a very long link. And lastly, we download the piece in order, so you can start to process what you are downloading while it's downloading. So now for the infrastructure part. So if you want to develop artificial intelligence and you want to do the artificial intelligence algorithm and stuff like that, you don't necessarily want to deal with all the infrastructure under that. You don't want to be this guy. And for that, we propose to use TensorFlow and Hadoop. So why TensorFlow? If you were there 2 presentations ago, it was 2 or 3. You saw that there is a lot of existing system to do deep learning. We choose TensorFlow because it's the big one right now. It's the one everybody uses. It's Google behind it, so I guess it's help. I'm personally more developing the Hadoop part, so I don't know so much about TensorFlow. I'm sorry about that. And then we think that Hadoop is good for, because you want to have big data, as I said at the beginning. The data you need to train your right now, TensorFlow on Hadoop is not so good. It's the reason is that the way people do it is that they have the data in Hadoop, they have TensorFlow on another machine, and they take the data to where TensorFlow is. They run TensorFlow, they run their algorithm, and then they put back the result in Hadoop. This is not efficient. Luckily, there have been now it has been developed a system so that you can, from TensorFlow, use data that are in Hadoop. And in our platform, we have integrated all of this together so that people can directly run their TensorFlow job in the plane on using data in Hadoop without having to do all this transfer. It's not perfect yet. There's still a lot of work to do. And this will be part of our future work. So I will just do a quick demo of our system. The resolution will be shit. So or will I? So the thing is that we run this platform. Okay. So the thing is that we have a data center in Luleå in the north of Sweden. The same place where Hadoop have their, where Facebook has their European data center. I guess it's. I just want to zoom out. Nee. Okay. Oops. I'm lost.
Yeah, it's English.
Yeah, but I use the Swedish one. Yeah. Okay, so the idea is that we have a front end for our Hadoop system, and we have a project system where everything in Hadoop is a project. Inside projects, you have users that have different roles, and we ensure isolation between the projects. So if you have data in Hadoop and they are part of a project, you know that people that are not part of this project can't access to it. And then we can go to SpaceNet. So on this data center, we give access to our students of the deep learning course, and they did their homework on it. And one of the group did the SpaceNet challenge. So it's the idea on and they run it on the cluster. They just went to Zeppelin and in Zeppelin creating notebook. And the idea of SpaceNet is that it's a satellite picture of so these are the notebooks. This is all TensorFlow code. And there's some pictures, so it's some satellite picture of the Rio area, and the goal is to recognize if there is building in the picture. And you can see that when there is building, it's isolate the part where the building are. I went too fast. So, yeah. So as you can see with this platform, it's easy to download new data set and to start working on them with Zeppelin. Yeah, it's taking time. Okay. Come on. Okay. So future work. I only wrote the future work concerning TensorFlow because it's the only part I spoke about for platform. So something we are working on right now is a distributed TensorFlow. So this exists, but this is we don't think that the implementation is so good right now, and it's not. It doesn't work on Yarn. And as we want to run it on top of Hadoop, we want to run it on top of Yarn. So we have some people working on that, making that you will be able in the future to say, okay, I want a cluster with these machines, and I want to run this TensorFlow program on it, and then Yarn should take care of that. Then that means also adding some thing to Yarn, because we want to be able to run with InfiniBand on GPUs, which Yarn doesn't handle right now. Right now, Yarn only handles CPU and memory. So we are also working on adding this information into Yarn. So as I was saying, we have a cluster up in Luleo. It's already used, so it's code that are I have no idea. That is in production, that students and researchers are using. If you want to test our code or platform, you can either go to hops.io, and then you have Vagrant. You can deploy the full stack with Vagrant and start to play with it. We can also give you access to our cluster in Luleo, but you won't have access to the GPU cards because we don't have enough, so we keep them for ourselves. Then I just want to thank all these people. So we have a lot of alumni because we are research people, so it's a lot of students that have been working with us and that have done a valuable work. But as you see, we are quite a small team working on this project. And we created our startup to develop it. It's called Logical Clocks. And then we are looking for people that want to either use our system and give us feedback or develop it. It's all open, so you can go on GitHub or ops.io and have more information about us. Thanks.
Questions? Any questions? Well, thank you so much again.